Hello, everyone, and welcome. It is another Wednesday, and it happens to be the third Wednesday of the month, which means we are doing the Rock ID videos for our Patreon subscribers. So these are people on Patreon who've paid $25 a month to be a Rockhound supporter, and they submit a video once per month. And every third Wednesday, we look at it as a crew, and we go through it and give you our best opinion as to whether it is or is not a meteorite, or if it needs more testing. And obviously, if we find something that's interesting, and we will help you get it to the next level. So that's hopefully what we're going to accomplish today. All right, let's take a look at our first submission. This is from Travis. It was found in northeastern Ohio. So Marissa, this is in your backyard. Found in 2024, weighs about a pound. It has moderate attraction to a magnet, and it does not pass a streak test. And we're going to have someone talk about streak tests and also lab results and nickel testing. So we have a lot in this episode. The submitter's video did not really describe what features they thought were meteoritic, so that kind of puts us at a disadvantage, but he did say it resembles a Martian sugartite umgala. So let's take a look at I think we have a picture, and then we have a video, guys.
Total weight, 1 pound. Found in northeastern Ohio last year.
I don't know if there's audio on this. Can you guys hear audio? Okay.
Possible Martian scratch test. Light brown. The interior. Magnetic. This piece weighs 114 grams. Somewhat of metal content, maybe. Magnetic. Slightly. Let me know what you guys think. Thanks.
All right, that was our first video. We do have some people's hands up, and wow, we have Bruiser in first place. What do you have for us, man?
My initial feeling is it's not a meteorite, but my comment is more on the taking of the photos and how it's made it difficult to analyze, because he's holding his camera in one hand and holding the rock in the other hand. So you've got two moving things at the same time, and it just makes it blurrier. It may look okay on a video, but for looking at the details, it gets to be very hard. So putting, at least one of them down, or better, both being down to show the smooth face, the broken face or cut face, or the details of the exterior, it would just make it so much easier to help identify things. And especially, and again, also the lighting, you're going from dark to light, it makes it difficult. But here it's like, it's going in and out of focus, so it's kind of hard to really see. So
yeah, I appreciate your feedback. It's hard. It is hard to get the thing in focus for more than a few frames at a time, and that kind of does handicap our abilities to give scientific diagnostic feedback. So I appreciate that. Allison, what were you able to see in here?
I've got a few things to say. I don't see any external features that really ring alarm bells to me that say this is a meteorite. There's no fusion crust, no regmaglyphs. It's kind of got an especially round shape that I don't love as far as it being a meteorite. Kind of looks like, I hate to take the words from Pat, but kind of like a river rounded cobble. Weather rounded cobble even. It just doesn't quite have the right external features for me. And the magnetic attraction is bothering me just a bit as well, and hopefully somebody can talk more about that.
Awesome. Thank you very, very much. I appreciate it. Art,
Thank
what do
you.
you have,
Thank you,
man?
Travis, for your submission.
Appreciate it.
Comment that Bruce made about holding the object that he's photographing with one hand and the video in the other hand, that makes it very difficult for certain. But I'm not seeing anything that shines as far as extraterrestrial. That more or less looks kind of crystalline, and I'm going to go towards like a chert nodule, you know.
Yeah, I can see that. Awesome. Thank you very much, Art. Appreciate that, man.
Sure thing.
We now have Mike Kelly. What do you have on this one, man?
Evening, everyone. So what I was thinking is I don't really see anything that looks like feldspars in there. So you're missing a component that I would typically think if he's leaning towards Martian. It looks pretty ultramafic. It's got a lot of dark minerals in there. One other thing is, right, meteorites, a lot of times when you cut something open that large, a lot of them would have shock veins in there, right? And you're seeing a very smooth, even interior with no indication of any shock. And just to second what Allison said, the exterior doesn't really have like a weathered, even crust look to it, even though it's smooth and rounded, right? You kind of have that pitting nature to it that you wouldn't get for something that had been ablated in flight.
Awesome. Thank you very much. We got 30 seconds each on the clock for Dave and Pat. Dave, what do you have?
Okay, so to address the magnetic part, a reminder on that, putting a magnet to what you think might be a meteorite is kind of the last part, because the first part you want to see if it does have all those characteristics, and everybody so far has listed beautifully all of those. And again, the interior looks very, very smooth, very reminiscent of an earth rock, and there's no inclusions or anything that would indicate it would be a meteorite. So the fact that it still sticks to a magnet is, again, you drag a magnet through the beach and you're going to get a lot of black sand to attract to it. So there's a lot of earth rocks that will attract to a magnet. But that would be the last test when it says, wow, that looks like a meteorite, it sticks. And then even then you have to be sure. And this one doesn't really pass the test.
And I'm going to piggyback on you. I'm going to steal 5 seconds of Pat's time. No. Mars material, because that's the only thing that the submitter said that he thinks it may be, is it says it looks like Martian. Yes, I agree. On the interior, it does look, you can convince me in a low res moving picture that never is really 100% in focus that it may be similar to Mars. But when you stick a magnet on it, Mars is not known to be magnetic. So you're arguing points against yourself a little bit. That's why some of these tests are cumulative. And when we ask you on these submissions to do all these tests, because it really does help us when we see how the magnet attracts to your sample versus how we know it does react with Martian samples. Pat, last words, buddy. I don't think we can hear you.
I think what Pat's trying to say is it's ultra homogeneous. The Earth, the Moon, and Mars are made out of the same things, so it's hard to tell sometimes, but that looks like an Earth rock. Thank you, Travis, for your submission.
That's awesome.
Okay, I'll try again.
There we go.
So basically what Allison said, same color inside and out. The interior is basically featureless. Yeah, there are some crystals in there, so it's, probably not a quick cooling basalt, but maybe a slower cooling basalt. He mentions metal, but there's so many reflective crystal surfaces in there that have a semi-metallic sort of look. And Allison's right on with the shape is right for a water-worn river cobble. And in my experience, a huge percentage of earthly basalts will attract a magnet as well. And again, Allison was correct. The same protoplanetary disk that formed Earth also formed Mars and the Moon.
Thank you guys very much. And we did have this on here as well because we want to keep on educating people and showing examples of streak tests. And this is kind of the two results you can get from it. There's 3 results you can get from a streak test. No streak, a reddish brown hematite streak, or a grayish black magnetite streak. So when people say it did a streak test, it passed a streak test, it made a streak, well, that's kind of not what you want. So this is a magnetite and hematite, and when he did the scratch test, it looked a lot like magnetite to me. So we are going with a crew opinion of 100% terrestrial, probably magnetite, weathered and worn into a round state naturally. We are going on to meteorite submission number 2. This one, let me see here. We have, we actually have lab results on this. So Pat, we're going to come to you. If you could have a little bit of information on those lab results. I think that we sent them to you in advance. Good. Awesome. All right, here we go. This is from Jessica. And Jessica did a nickel test as well. This is a good, we love having more information. We love having data. Every little bit helps. And Mike, can I tap you on the shoulder to talk a little bit about the iron test?
Nickel test? Yeah, sure.
The nickel test. Thank you. Yes, exactly. Now, this was believed to be found in Michigan. Now, this is something I'm not familiar with. This is a direct quote, so we wanted to put it on here. It does attract to a magnet, but only if it's floated in styrofoam, which to me means it's a very, very, very light magnetic response, but I don't know what paramagnetic is. I hope it's not ghosts of magnets. The submitter didn't really tell us why, Jessica, why she thought it was a meteorite. She didn't really point out any meteorite features, which is always extremely helpful. She did give some paperwork, some lab results, and chain of custody, and all that's really, really good to have. And Pat's going to give you some information on it. So let's just I'm going to show these to you real quick so you guys can see what we're looking at as far as the test results that she has. I think there's 3 of these, and Pat's going to have we're going to come back to these for you later on, Pat.
All right.
But this is the sample.
I'm taking it in the window light, but we live in Michigan, so the window light's not the best. Therefore, I had like a little ring light camera I tried to use to give it a better view. And then here in a second, I changed the lights so that you can kind of get an idea of, what it looks like in different hues of light. I have had this nugget tested by assay. However, the United States said they don't do platinum testing because platinum is too volatile. So that's what we've got. I also did a nickel test on it, and it did come back with nickel.
Okay, here's the nickel test.
Will it turn pink?
Now, another thing I'm going to mention this rock has been broke open for 2 years and has not rusted. And look at that, it's definitely pink. That means there's nickel.
Mike, I'm going to go to you for the nickel testing. How helpful and how accurate are those off-the-shelf at-home nickel tests?
Okay, yes. So nickel tests are a helpful thing. They're not a solid indicator because just as, meteorites pretty much for the most part all have a small percentage of nickel in them. There's a lot of terrestrial things that have nickel in them, not necessarily rocks and ores, but definitely high silicate byproducts of the manufacture for things like stainless steel, which has nickel in it. So again, it's a okay indicator to say something has nickel in it, so it's more likely to be a meteorite than if it had nothing in it and you got no results, then it would likely not be a meteorite. But it's not a 100% positive type deal where we're making classifications based on a nickel test like that. Now, as far as the color goes, right? So that's the hard part is a nickel test doesn't tell you how much nickel is in there, right? So you could have very low parts per million with those type of nickel tests. They're designed basically for skin allergy reactions, which is around the 10 or 11 parts per million amount, right? So that means that there could be very, very little nickel in there and you'll still get a positive result like that. That test is really designed to turn like, so the insoluble salt that's produced by that is a red product, right? So the darker it turns, the more nickel is obviously being picked up. So that's a pretty light pink. So it's probably a very low percentage in there.
Awesome. Wow, that really helps. That's some good information. Thank you very much. You're talking about parts per million in that versus meteorites. You're talking about maybe 3 and 4% and up. So, Pat, did you have any comments on these lab tests?
Yes. So what we've got are a set of 32 elements with percentages, and in this case, they're not mixed ppm of percentage, they're all percentage. And 10,000 ppm is 1%. So we're seeing iron, 41.8% Fe, right? And now that's not metallic iron, that's all iron, whether it's in the form of rust, magnetite, hematite, etc. It's everything. And we have a number of other elements that are expressed down to, the few hundreds of a ppm, like for cerium, they're 0.007%. That's 700 ppm. But noticeably absent are cobalt, and we should expect to see some cobalt in a meteorite, and nickel is also completely absent. And so that means that nickel was below the limit of detection, and we can see from these numbers that limit of detection is quite low. And for manganese, there for Mn, just a little less than center, that is right in the same energy level where we would see the peaks for nickel. So we've got 41.8% iron and no nickel. So that indicates not a meteorite. And that's what I have. Thanks.
Fantastic. Thank you very much. Allison, was there anything in the video that you could glean that you want to comment on?
I wanted to just make comment. She had made comment about platinum, doing a platinum test on that. And as far as I know, platinum would be even less common in even a metal meteorite than the nickel iron would be. So if we're looking at doing a platinum test next, then that would lean way outside of the realm of meteorite, I would think.
I agree with you, and I'm glad you brought that up because I couldn't hear the audio, so thank you. I'm gonna summarize for the crew. Unfortunately, this is another case where the video is not the best quality for diagnostic purposes. This is probably one of the few frames where we can actually see the surface lit, in focus, hand not in the way, and I don't see anything. I honestly don't see anything that I think is meteoritic here. To me, it looks like it's glistening. I don't see any meteoritic features at all. The chemistry of it, self-reported chemistry, is not on for meteoritics. It doesn't pass our muster test. So I'm going to go ahead and say that nope on that one. It's too small, and it's not enough diagnostic quality video for us to have any other opinion other than no. So I apologize for that. this is our third submission for the day. This is from Ty. And the rock was found in southern Michigan. I think this is a second one from Michigan. Wow. In an orchard that had just been pushed out and tilled under. So believes that the sample may be a stony iron, but not quite sure. The actual weight is 340 grams, and the attraction to a magnet is tested, but I don't know what the result is. So we'll see. Oh, this is features that the reporter is seeing themselves. This should be a pretty interesting sample with all these things visible. Let's take a look at it. I think we have some photos first. I wonder if those pebbles are embedded on there in a layer of caliche or additive material to the rock. Maybe someone has an opinion on that. I do see what could be confused or could be called shock veins, especially this right here. It looks like there's a different patch of material on here. So is that what she could be referring to as fusion crust? Maybe someone have an opinion on that. Are we seeing contraction cracks?
Looks like it's 342 grams. Some spots it's a weaker attraction than other. Here, it's not really, because I do believe that this is some kind of stone right here, like on the outside there. All right, so this was found on a family-owned 100-acre farm or so, one that in Southwest Michigan. That it was in an orchard that had recently been pushed out and disked under. The features that I see, I feel like they're similar to a stony iron meteorite. I was trying to figure out which one, but I'm not really sure. But so it's the features are that it's attracted to a magnet. This area here, as well as some others, could be representation of a primary fusion crust, like here and around here. Just the glossier areas. This area here, and then these like rougher areas right in here they seem to be similar to what I've seen you guys describe as like a secondary fusion crust. So like right there. And so here are what I see as maybe what could be representation of some shock veins here. And you can follow them around into the inner areas of the rock. You can follow this around here. And then, so this one especially goes through here into here. Here's another secondary fusion crust that I feel like seems like that. I did file a window here. You can see this crack meets up with this one here. This is the only place that I would consider maybe a contraction crack. I thought maybe this could be maybe a representation of pooling, if this is the if this was the orientation. This is the area that has crystals in it. Oh, there is examples of like rust and stuff on the inside, which would make sense why it's attracted to a magnet. This crack here does line up with the line, which would I consider a raised shock vein here. Okay, thank you.
Well, now, I'm at a distinct disadvantage because I couldn't hear the narrative, but it was interesting to see what was being pointed at, and it was actually in focus. So well done. Let's start off with Dave Pinsky since he was first, and then Chris next.
It was hard to really see that would be fusion crust. After seeing weathered meteorites many a times, it has a distinctive look, and this just looked like just a rock that's weathered. The interior doesn't look that much different than the exterior, except for the fact that the exterior has been sitting in the ground for a long time. I didn't see anything that indicated contraction cracks the way I would normally see them. These look more like a cracks throughout the rock.
Thank you very much, sir. Sanders, over to you.
Yeah, I was looking at what she noted as potential fusion crust, and I think for me, the texture of it and the way the light is bouncing off of it is what looked odd to me. You know, with fusion crust, it's hard to, until you look at it really close, it's hard to really visualize, but it's like frothy, right? It's almost like a frothy texture, and it's not like glossy like this so much. And this almost like glossy, and the light is reflecting pretty hard off of it. So that didn't really scream fusion crust to me. And then I think at some point she mentioned the potential of like flow lines. There was some lines she was pointing to in the area she thought was fusion crust. And it's hard to tell from the focus of the camera and how quick she was moving, but they looked like they were like inset or cut into that black area, and I would expect the flow lines to be kind of raised from where like the fusion crust melted when it was coming in. So those things did not jive meteoritic to me.
Thank you. I appreciate that. Bruce, do you have any opinions on this one?
Yeah, I kind of agree with Dave and Chris. I can see why, looking at it, you might think that it's a meteorite, and you know, depending on the angle of light, there are certain things that look like it. You know, I can see why, you know, she's thinking that some of this is fusion crust. I can see why you know, the shock veins, and the fact that that piece came off and it looked like it was surrounded by a shock vein, because I think on the smaller piece, which really didn't show too well, like kind of looked like it had the shock vein. But what really tells me that this is not a meteorite is when she was turning it around, and then she said, here's where I windowed it, and I'm like looking at it, I'm like, that's a window. It's like, it looks the same as, you know, if it wasn't windowed. You know, the inside is the same as the exterior. So that's what I got.
Awesome. I appreciate that. Allison, do you have any opinions on this one?
It was definitely the window that was the tell for me too. I mean, a lot of the rock, I'm gonna totally agree with the fellas that went earlier and discussed, you know, fusion crust and contraction cracks and all of the things. But again, for me, when we turned it around and looked at the window and looking at it now, how sparkly it is and things.
Exactly. Thank you.
I always take notes, Ty, as I watch these videos, is things I want to come back and talk about. And one of the things that I noted very first was that we were assuming in some way that this is a stony iron. And so let's take it right back to the basics, you know, the three types. Irons, which we all agree this is not an iron. Obviously, we the viewer included does not believe this is a chondrite, and believes that this may be a stony iron of some type, which is a palisite. So when we think about a palisite or a stony iron, I just want to clarify that so that we're all on the same page. We're talking about like a chrome bumper with, you know, yellow or green olivine inclusions. And I see a spot on the end of the little nub where she talks about there being a stony inclusion. And to me, it really kind of looks quartzy. It's kind of white colored and it kind of looks a little bit quartzy. So I'm going to have to kind of disagree a little and say probably not a stony iron. And when we break it all the way down, it doesn't really kind of fit into any of the boxes, iron, stony iron, or palisite for me. But the window was aces. Thank you for including a window, Ty. That was great.
Yeah, that kind of look really does help. Pat, thank you very much. Pat, do you want to clean us up on this one?
Yeah.
Please?
So I will say to start off, this thing's about the right color. You know, if I was wandering around looking for weathered meteorites, this is the right color. But I think that's kind of where it ends. So early in the video, she showed an area that looked like a sand concretion, where there were little sand grains stuck to it. That's very common in iron-bearing earth rocks, and I have seen it on meteorites as well. Yeah, those are grains of sand stuck in hematite or some other iron compound. What she was showing as shock veins, I think probably are more likely hydrothermal veins that are sticking proud of the surface. We have a couple of meteorites with hydrothermal veins, but super, super rare. The overall color of this really is indicative of a weathering rind rather than fusion crust, either primary or secondary. She shows a crack there and references contraction cracks, and contraction cracks only go the depth of the fusion crust, which is, you know, less than a 32nd of an inch. The one real tell for me, though, was when she lifted out that piece out of the corner, and we see some very small, very druzy looking crystals right
Here.
there. Yeah, yes. You see those little druzy crystals. You don't see that in meteorites. And also, you know, we see no chondrules. And if she's arguing that it's a stony iron meteorite, they contain a considerable amount of metal, and her fridge magnet would stick like crazy. That's what I have.
Thank you very much. I really appreciate it. Crew, once again, I couldn't have done this without your help. You guys came through with spades, and we got some really good information out for our Rockhound emitter. So I really feel like we did a good job identifying these as terrestrial samples and even possibly what they could be. Art, I'm sorry I left your hand hanging, but we're out of time, so we'll catch you guys next week. Thanks for watching, everyone.